Okay, video game company sells 132 games a month. Standard deviation of 9 games. Companies are looking for the top 7%. So if we're going to assume that it's normally distributed, which we have to in this problem because they give us a z-score table, then we can find a z-score that corresponds to the top 7%. So you want to find a number. Like z equals 0 is the center. That's the 50% mark. We're trying to find the z-score so that it cuts off 7% in this tail up here. So to find that z-score, we have to know something about how the table works. And the table is giving you a percentage of the, it's giving you probabilities less than the z-score, so the area to the left. So the table only gives us this area. So look, if you want 0.07 for this area to correspond to 7%, then you want 0.93 over here. And if you look through the sea of z-scores, 1.47 is the correct z-score because I just did a little battleship. Probably 1.475 because look, that's 0.929. That's pretty close to 0.93 that we need. Okay, so again, the top 7% means we want 0.07 for this area. But the table only gives us areas to the left, so we want 0.93 for over on this side. So I'm going to use z equals 1.475, halfway between this one and this one, okay, because 0.93 is halfway between those two numbers. So z equals 1.475. Okay, so they're asking, oops, I didn't mean to delete that. Z is 1.475. Okay, so originally I misinterpreted what this question was looking for. They're asking what is the mean per store that they need to sell. So there we go. So the formula we need, if we're ever trying to calculate something about x bar for the mean, then we want to use this version of the z-score formula. It's just a slight adjustment. The standard deviation needs to be divided by the square root of the sample size like this. Okay. So z, we found out, is 1.475. X bar, that's the mean that we're trying to calculate, so that's still a variable. But the mean per store they give us, it's 132 games is the average, so that's the mean. And then the standard deviation was 9, so that goes in for sigma. And then the sample size, sorry, that should say n, but the sample size is 36 in this case. Okay, so let's figure out what the standard error of the mean is. That's going to be 9 divided by 6, right? Because square root of 36 is 6. So the bottom is 1.5 in this formula. So if you're trying to get x by itself, I've just rearranged this. I've simplified it, right? So if you're trying to get x by itself, I guess I don't have to scratch that out. You just have to multiply 1.5 to both sides of the equation, okay? Because that gets rid of it in the denominator. So you want to do 1.5 times this and 1.5 times this, and that makes 1.5 cancel out. So I got to do 1.475, our z-score, times 1.5. That's 2.2125. And then we got to add 132 to both sides to finish getting x by itself. So when we do that, we got a mean of 134, and then what do they want us to round to? Nearest whole number. Round x bar up, it says. So this is our x bar, but we're supposed to round it up, so we bump it up to 135 according to their instructions. Okay, so that's how many they need to sell on average per store. So I think this question's similar, except this one wants the lowest 5%, right? So here's our z-score. If you want to find a value that represents the lowest 5%, you want 0.05 in the left tail. And the table is working in our favor in this case, because remember, the table always gives you values to the left. So these two numbers are close to 0.05. So we'll take the z-score that's between them. Negative 1.64 is this. The z-score negative 1.65 is this. So we'll take z equals negative 1.645, right in the middle between those two, since 0.05 is between those two numbers. Okay, so that's our z-score. We'll plug that into the formula I just used in the question above. They want us to calculate the mean again. It says round the z-score to 2 decimal places. I didn't note that in the last one. So you're supposed to round to 2 decimal places. So when you enter your z-score, it should be 1.48 there, okay? So this z-score, they want us to use negative 1.65 because I said round to 2 decimal places. So I missed Newton's instructions there, so scratch that out. Okay, that's our z-score. The population mean for this one, mean of 0.45 inches. And then the standard deviation is 0.05. I'm just using that same formula we put in the last one. You divide by the square root of the sample size. Okay, so negative 1.65, trying to get x bar by itself. I can figure out what square root of 65 is in my calculator. And then it's 0.05 divided by that square root. So this is our denominator. Okay, so the numerator is, I can't click it. The numerator is x bar subtracted by 0.45. And then we divide by the standard error of the mean, which we just calculated with that calculator. It's not copying though. Take this many decimals. Okay, so if I'm trying to get x bar by itself in this problem, I need to get this out of the denominator. So same step as last time. I want to multiply by the denominator. 0.00620, I'll round there. I want to multiply this to both sides of my equation. Okay, so if I do that, 0.06202 times negative 1.65, that's negative 0.0102. I'm running out of room. Okay, what do we get? Negative, and that's a negative 0 because it's a positive times a negative. So negative 0.0102 3. You can probably carry out a few more decimals if you want and it won't hurt. And I'm still trying to get x bar by itself, so I got to make this disappear. So the opposite operation algebraically is to add 0.45 to both sides. So that's negative, and I'm adding it by plus 0.45, and they told us to round to the second decimal place. This is 0.44 for our mean. And then the z-score we said is negative 1.65 because they told us to round to 2 decimal places. So I don't know if Newton's error tolerance is going to accept this answer because Newton actually rounded something a lot earlier that they didn't tell us to round. So all those steps are correct, okay? But let me show you what Newton does. Newton calculates the standard error of the mean separately. They don't just plug it into the formula. This is the bottom part of that formula that we keep doing. It's the standard deviation divided by the square root of n. So Newton does that separately. It's 0.05 for the standard deviation, and a sample size of 65, so that's the square root of the sample size. And then 0.05 divided by that gives us, that rounds, they round to the second decimal place here. And I don't think it says in the instructions. It doesn't on this one. It doesn't say to round the standard error. That's awful. So that's 0.01, which is way less accurate than what I just did, right? Because that 6 causes you to round up, but you've cut off a lot of decimals, and that's going to change the answer just enough so that Newton would mark it wrong. But that's a pretty silly reason. Okay, so negative 1, just repeating the calculations real quick, negative 1.65 we said because we rounded to the nearest decimal. Look, this is the denominator of the fraction, right? So they just rounded that off. So just watch out for that. So I guess for students doing this problem, I assume that you're always supposed to round the standard error to 2 decimal places, even though Newton doesn't say. I'll put in a ticket to try to get Newton to specify that, because if that's what they want students to do, students are going to get it wrong when they might actually be doing the question right. Okay, so I'm doing the same thing I usually do, multiplying 0.01 to both sides. So that's negative 0.0165 equals x bar minus 0.45, and then add that 0.45 to both sides. So this is just positive instead of negative. And then they want us to round this. Oh no, even with that, it doesn't make any sense because that rounds down to 0.43. So I'll show you what I'm seeing on Newton's screen. Oh, this is a different question. Oh no, Newton says 0.43. Okay, so that is what they say. Right, but it's crazy. If you don't tell students to round to the second decimal place and they keep all the decimals, they're going to get it wrong when they're doing the question right. So I'll put in a ticket, but it probably won't be fixed for the current term for where this video is being made. But